Okay, this one's going to be a relatively quick one today. So we're going to be looking at the theories of the purpose and function of sleep. So the first theory is the restoration theory, and it's also called the recovery theory and the repair theory. So it proposes that sleep provides a timeout to help us to recover from depleting activities during waking time that use up the body's physical and mental resources. So sleep gives us an opportunity for the body to recover by replenishing resources that have been used up during the day, including neurotransmitters that are vital to communication between neurons. So sleep helps to recover not only the body but also the mind. So it allows damaged cells to be repaired and various muscles to be detoxified or rid themselves of waste products. This view is supported by the experiences most people have of feeling tired before they sleep and feeling refreshed and more energetic upon waking. It also suggests that if you happen to be exerting yourself quite physically throughout the day, you're going to be sleeping longer. So another restoration idea is the whole idea that NREM sleep is considered to be important for restoring and repairing the body, right? So your body is recovering during NREM sleep. For example, physical growth, tissue repair and recovery from the effects of fatigue may occur during slow wave stages 3 and 4 of NREM sleep when the brain is least active. They also argue that REM sleep is more abundant in the fetus and in infant than in childhood and subsequent lifespan stages. So it's suggesting that REM sleep may play an important part in the peak period of brain development that occurs in the early stages of the lifespan. So they're saying that NREM sleep is important for repairing the body, whilst REM sleep is important for restoring the mind. So they're saying that REM sleep has a restorative role throughout the lifespan, not just in infancy. And this is because it provides a regular exercise to a group of neurons in the brain that form neural pathways and promotes maintenance of brain circuits. So it helps the brain to function and it helps to connect neurons more. And that's why they're suggesting that REM sleep is responsible for the consolidation of memories. And you may want to circle that bit there, the consolidation of memories. So REM sleep is apparently responsible for the consolidation of memories and brain restoration, whereas NREM is responsible for body restoration. So in other words, restoration theory is the idea that we sleep in order to restore the body. REM sleep is a restoration of the mind. NREM is sleep is for the restoration of the body, and REM sleep is for the consolidation of memories. Theory suggests that newborns spend 50% of their sleep in REM sleep because their brains are still developing. So, a part of this theory is REM rebound. So psychologists generally agree that REM sleep probably serves an important biological need, and it's most likely to do with the brain. In the controlled conditions of sleep laboratories, people have been woken up each time they lapsed into REM sleep with no obvious ill effects. So each time you went into a REM sleep, they would wake you up. So you'd never have REM. But what they worked out is the following nights, when they had uninterrupted sleep, they spent more time in REM, indicating that there is a need for REM sleep, and that if you lose it, eventually you have to make it up. So this is called REM rebound. So REM rebound involves catching up on REM sleep immediately following a period of lost REM sleep by spending more time than usual in REM sleep when next asleep. Another theory of sleep, or the purpose of sleep, is the evolutionary or circadian theory, also known as the survival theory or adaptive theory, and it pretty much proposes that sleep evolved to enhance survival by protecting an organism through making it inactive during part of the day when it's most risky or dangerous to move about. For us, our most dangerous time to move about is nighttime. And the reason for that is because we can't see in the dark as well as some animals. So it's risky for us to move around at night time. So they're saying that we've evolved to a point where we sleep at night to protect ourselves from predators. So according to the theory, once an organism has fulfilled its survival functions such as eating, drinking, and caring for its young and reproducing, it must spend the rest of its time conserving energy, hidden and protected from predators. While sleeping, an organism is not physically interacting with the environment and is less likely to attract the attention of potential predators. According to the theory, sleep serves the function of protecting the sleeper from harm or death and therefore enhances survival of the species. And it's a good theory in theory. It does have some issues. We'll get to that. So, for us personally, the sleep-wake cycle is regulated by circadian processes that are tied to light-dark changes and support the safer lifestyle by ensuring that scheduling of activities and biological functions at appropriate times in the daily environmental cycle. So we sleep at night because we cannot see at night. So some research into the circadian theory. So an animal's typical amount of sleep depends on to a significant extent on how much time it needs to obtain food, how easily it can hide, and how vulnerable it is to attack. Large animals that are vulnerable to attack tend to sleep little. Large predatory animals, which are generally not vulnerable, tend to sleep a lot. So think of all the lions. When you go to the zoo, every single time they're always asleep because they have no natural predators. When considered from this perspective, humans sleep at night because we are highly visual animals who need light to find food and do other necessary things for survival. Consequently, we are not well adapted to searching for food in the dark or protecting ourselves from nocturnal predators. It may have been best for us during most of our evolution to be tucked away asleep at night in a cave or other hiding place so as to not be tempted to walk about and risk falling off a cliff or being attacked by a nocturnal predator. Now, the reason why they say most of our evolution, in this current point in time in our history, we can actually see at night because of all the additional things that we have at our disposal. We have artificial light. We have, torches and things like that that help us to see. Still not a good idea to be going out at night time, especially after 8 o'clock. It's not allowed. The issues with this theory. It's an interesting theory, but it's not the one that's mostly accepted. The mostly accepted one is the restoration theory. So the evolutionary or circadian theory is useful in furthering understanding of the purpose and functioning of sleep, but there are some issues. It doesn't actually explain our need for sleep. It just says that we do sleep, but it doesn't say why. So why we and other mammals must and will eventually sleep regardless of the environmental circumstances and possibly the danger to which we may be exposed to if we fall asleep. So let's say, for example, you've been awake for, 4 days. At some point, no matter where you are going to fall asleep. And it doesn't explain why. Nor does the theory account for the loss of awareness and alertness during sleep, which since their loss may result in putting the organism at greater risk. So it doesn't explain the fact that we actually sleep during the time that predators are out, which makes us more vulnerable because we don't know that they're there. So we are more vulnerable, which kind of makes the whole theory out the window. So in other words, the evolutionary theory suggests that we as a species have evolved to sleep when we are most vulnerable to predators. So we move less, therefore are less likely to attract predators at night. According to the theory, bigger animals sleep less as they are less likely to be hunted by predators and take longer to meet their basic needs. The theory doesn't account for the fact that by sleeping we are now more vulnerable to predators. Either way. Alright, differences in sleep patterns across the lifespan. So sleep patterns change considerably with age. From infancy to adulthood, there are marked changes in the proportions of REM and NREM sleep, including the percentage of time spent in each NREM stage. Now, we are going to go into details about this because this particular graph is super important. Make sure you know it. So, we're going to go through this. You must know how to read this type of graph. So down the bottom here is the various age groups. The orange is NREM, the purple is REM, and these are the amount of hours at each level. My advice would be to copy this table in and then copy this as well as notes underneath. So for a neonate, and a neonate is somebody, an infant in, 1 to 15 days old, right? You spend 50% of your sleeping time in REM and 50% in NREM, and you get 16 hours of sleep. So when I say 50% and 50%, it's not your whole day, it's just 50% of your sleep. Infants, so 3 to 5 months, you spend 40%, so it's this one here, in REM and 60% in NREM. So it's saying that the brain is still developing during this time, and you get 14 hours of sleep. Infants 6 to 23 months, you spend 30% in REM and 70% in NREM, and you get 13 hours sleep. So till about the age of 2, you should be sleeping about 13 hours. Alright, so the next lot. This is your children, and I've sort of lumped them together. So 2 to 12 years, it's approximately 25 to 18.5% of your time in REM, and then we're looking at about 75 to 80% in NREM, and you get about 12 to 10.5 hours per night. In adolescence, which is where you guys are roughly at, you've got 20% in REM and 80% in NREM. Now you can see here that at 13, around that time there, you're actually getting less REM than what you do when you become a teenager, and that's usually this restoration theory suggests that because you're doing more taxing things on the mind, right? You've had to learn new concepts through high school. You actually need more REM sleep. So that's adolescence, and have a look at this, 8.5. But if you actually did a sleep diary, you would actually remember that you probably wouldn't get 8.5 hours of sleep per night. I'd be surprised if you got that. Young adults, you spend 22% in REM and 78% in NREM, and you get about 7.75, so from 19 to 30. And then adults, we're looking at 18.9, let's go 20%, and then 80% in NREM, and 7 hours of sleep, so we're here. Then you'll notice around 50, start getting 6 hours of sleep. You might get about 20% in NREM, 20% in REM, and 80% in NREM, but the amount of sleep that you're getting has reduced. So this is how many hours you're getting, and then it goes down as you get older. So as we age, the amount of sleep we have decreases, as does the amount of REM sleep. So this is the amount of REM sleep, and it slowly gets smaller and smaller. Alright, so infants and newborns. From about 2 months of age, sleep onset may occur at any time of the day or night. So infants will fall asleep whenever they want. There's no set pattern. There's no regular rhythm, and there's no sleeping or waking times. You can't train a newborn infant to sleep when you want them to, despite all the books. It takes a couple of weeks, if not a couple of months, before they can actually be regulated into a sleep pattern. Sleep duration also tends to be irregular, and that could be depending on what they're eating, what they've done in the day, that sort of stuff. So the cyclic alternation of NREM and REM sleep is present from birth, but there are fewer sleep cycles. So you may only sleep for 30 minutes, which means that you barely get through one sleep cycle. Infants that are fed from the bottle tend to sleep for longer at a time than breastfed babies. And this is because there's a lot more, and I know I'm going to get a lot of complaints about this one, but there's a lot more fat and nutrients in the, or artificial nutrients, from the bottles and the formula than what there are in breast milk. Breast milk apparently has, the stuff that the baby needs. However, they've been able to create it artificially, which allows it to sleep longer. Infants spend a majority of their time in REM sleep. Go 50-50, people. Alright, so young children. Total sleep time continues to decrease as the child gets older, from about 13 to 11 hours between 2 and 5 years of age. This is usually attributed to maturation, so their ability to physically grow, and other biological factors, as well as social factors such as decreased daytime napping, the introduction of preschool time routines, and other changes that influence sleep. The proportion of REM sleep continues to decrease, and the amount of NREM sleep increases, with a greater percentage of sleep time spent in stages 3 and 4. So when you're an infant, you spend 50-50. So 50% in NREM, 50% in REM. When you become a young child, you start spending more time in more time in NREM, and then less time in REM. Adolescence. With increasing age, the total time spent sleeping decreases, as does the amount of REM sleep. However, if bedtime is fixed, the duration of REM sleep tends to remain constant. So if your parents are very strict about what time you go to bed, and you actually go to bed at that time, and what time you get up, your sleep time does not change from that of a child. However, hormones start to come in, and that thing called puberty tends to affect, which we're going to look at later. So research findings indicate that adolescents tend to get less sleep than they need to function at their best. One reason is a biologically driven change in their sleep-wake cycle that changes the timing of sleep, delaying its onset for 1 to 2 hours. And we're going to go into more detail about this. But the thing to remember is adolescents are getting less sleep than they should be getting in order to function properly. That'd be you guys. Adults. And I've seen this particular graph so many times in exams, so make sure you know how to read it. So individuals vary their sleep needs, particularly as they get older, but most people sleep appreciably less as they age. By adulthood, we average about 8 hours of sleep per night, 20 to 25% of which is REM sleep. I doubt I get that. As an individual ages between the age of 20 and 60, slow wave sleep declines at a rate of about 2% per decade. By age 60, a severe reduction is evident. So you start losing stage 3-4 sleep. So people at age 60 may spend only about half as much time in NREM stages 3 and 4 as they did at age 20, sometimes not at all. Eventually, stages 3 and 4 disappear altogether. According to the restoration theory, it's because they're not as active as they once were, but they might be more mentally active. So, for example, reading, puzzles, all that sort of stuff. So if we look at this particular graph here, this is an adult, right, or a young adult. This is an elderly person. See how the young adult looks fairly normal to what yours would be. You've got stages 3 and 4 there, and you got, so they get to stage 4, they miss stage 4, but they go to stage 3. And it's fairly, there's 1 or 2 awakenings, so those yellow bits are awake. In an elderly person, there's only 1 stage 3, and they never get to stage 4. But there are so many awakenings. So at all points during this night, they have woken up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then they're awake. So 16 times compared to 1, 2, 3. but that's technically twice. So that's a good indication that we're looking at elderly. If there's lots of awakenings, this is an elderly person. Adults also tend to become more sleep also tends to become more fragmented as we age, with more nighttime awakenings amongst old adults, like I showed. This is, in theory, because there's a decline in NREM stages 3 and 4, and we are harder to awaken during slow wave sleep. So they're suggesting that the reason why you awake more is because you're not going into stages 3 and 4 anymore. Right? So 3 and 4 is really hard to wake up from, but if you're only in stage 2 and 1, it's fairly easy. So younger adults may experience brief awakenings, but it might be for a couple of seconds and then you go back to sleep. Older people tend to become sleepier in the early evening and wake earlier in the morning compared to young adults. This pattern is called advanced sleep phase syndrome. I've never seen it in the exam, but there's always a first for everything. So it's pretty much saying that because elderly people are going to bed earlier, they're waking up earlier. They're also sleeping less. So let's say, for example, my grandpa happens to go to bed at 7 o'clock because he's tired. Let's go. Right? But he'll be waking up at 4 a.m. in the morning, and he'll start his day then. And that's because he's sleeping less and he's sleeping earlier, so he wakes up earlier. Alright, notes to take away from the lesson. There are two different theories of sleep: evolutionary theory of sleep and the restoration theory of sleep. The restoration theory of sleep, it suggests that we sleep in order to restore the body. We spend more time in REM sleep to restore the mind and consolidate memories. We spend more time in NREM sleep to restore the body. Limitation of theory, it doesn't take into account that quadriplegic individuals still sleep a similar amount of NREM sleep when compared to others. Evolutionary theory of sleep, we sleep at night because we are vulnerable to predators at night. Large animals tend to sleep less as they are less vulnerable to predators. Limitation, it doesn't actually take into account the fact that we are more vulnerable when we sleep, and it doesn't explain why we sleep. Also, don't forget REM rebound, which is making up for lost REM sleep after a period of time where you do not experience it. So, a worked exam question. So how does REM rebound support the restoration theory of sleep? So this is 3 marks. Alright, so we know that REM rebound is part of the question. We know that restoration theory of sleep. Because it doesn't say define or anything like that, but it says how, you would need to actually define it. So it would be definition of REM rebound, definition of restoration theory of sleep, and then how it actually supports it. So, the restoration theory of sleep states that we sleep in order to recover from the depleting activities that occur during waking time that use up the body's physical and mental resources. That'd be 1 mark. Additionally, REM rebound involves catching up on REM sleep immediately following a period of lost REM sleep by sleeping more time than usual in REM sleep when next asleep. So that'd be another mark. According to, and this is the how part, according to the restoration theory of sleep, REM sleep is for the consolidation of memory and the restoration of the mind. Without REM sleep, this restoration would not occur. REM rebound is shown in sleep patterns following a loss of REM sleep, indicating that REM rebound occurs to rectify the loss of REM sleep and restores the mind. So that's pretty much what you'd need to do in order to get the 3 marks. Alright, you've defined, and then stated how it supports the theory. Alright, you can do the exam questions on your own. Okay.